Last class I have started deep foundations with this two types of deep foundation, one is pile and well foundations, and pile foundation I discussed, it may be provided single group of pile or battered pile. Then classification of piles also I have explained, short rigid, long flexible. Then also I have finished types of piles classification based on composition, method of installation and load transfer. Then let us start with this now, failure load. In failure load, let us start with this. This is your QU. This is your embedded length and this is your diameter D, and one is your point bearing, other is your shaft friction. So, if I write it failure load QA, Q allowable QA is equal to QB plus QF by factor of safety for pile foundation, generally it is provided 2.5. So, QB is your base load and QF is your skin friction load. So, in case of the values of QB and QF can be Q allowable used. So, if I go by independently, I can write it QA is equal to QB by a factor of safety generally 3 plus QF by your factor of safety generally 1.5. If you are going by, this is a pile, in this pile we have considered both end bearing as well as frictions. If only it is end bearing pile, for example, let us say this is the case as I have explained earlier, there is a load coming here and here it is. So, QA is equal to QB by 3 and QF by 1.5. So, these are the two factor of safety independently. If you are taking both friction as well as end bearing pile, then in that case total factor of safety will be 2.5. Now, in this case if there is a case here, then in this case there is a rock layer, what will happen? Load will be transferred by means of end bearing. Once it will be end bearing, then in that case QA will be QB by factor of safety of 3. Now, other case where load has been transferred by means of frictional resistance, in this case QA is equal to frictional resistance by 1.5. So, that is why this is your allowable load. So, now method of finding out, what are the different methods to find it out, ultimate load bearing capacity of single vertical pile, ultimate load bearing capacity of single vertical pile. So, there are different ways. So, there are different methods. First one is your using static bearing capacity equations, particularly bearing capacity equations, using static bearing capacity equations, then use of values of or using values of SPT, standard penetration test, and CPT, cone penetration test. Then by means of field load tests and by means of your dynamic methods. What I have discussed earlier, if this is your allowable load, theoretically you have to find it out what is the end bearing capacity, what is the friction capacity. So, to get that ultimate load bearing capacity of single vertical pile, first one is you are using static bearing capacity equations using values of SPT and CPT. SPT is your standard penetration test and CPT is your cone penetration test, and third is your field load test, fourth is your dynamic methods. Now, let us consider, first let me start with this using bearing capacity equations. Bearing capacity equations, first one by using your bearing capacity equations. So, for C5 soil, QB, because if this is my pile, this is a load, this is your frictional resistance QF, and this is your QB, base resistance. So, QB, if I write it Terzaghi's bearing capacity equations, it will be CNC plus Q0 NQ plus 0.5 gamma D into N gamma, gamma D into N gamma. D is your, capital D is your diameter of pile, capital D is your diameter of pile, into, because this is a capital Q, then area of your base, area of your base. So, this generally has been neglected for deep foundations. It is ineffective and neglected for deep foundation, So, NC, NQ and N gamma, NC, NQ and N gamma are bearing capacity factors, and if I write it, this is my L is your embedded length, L is your embedded length or depth of embedment, AB is your sectional area of pile at base level, and Q0 is equal to gamma into L, gamma is equal to effective unit weight of the soil. So, let me start with this. For this QF for granular soil, QF is equal to AS into Fs. So, QF is your shaft resistance AS is your shaft area, Fs is your unit shaft resistance, so for cohesion-less soil, I am going to next page. For cohesion-less soil, if I write it, let us take it a pile here, then this is your Fs, this is your Q, which will be acted upon by this is your delta. If I write QF is equal to AS Q0 prime Ks prime tan delta. So in this case Ks prime, Q0 prime is your effective overburden. So this will be a Q0, this is your Fs, and this is your delta, and Ks is your lateral earth pressure coefficient. Let me write it. Q0 prime is average effective overburden pressure Ks is your lateral earth pressure coefficient, then delta is your angle of wall friction. Similarly, for cohesive soil, QF is equal to AS alpha Cu bar. Alpha is equal to, this is your cohesion factor, and Cu bar is your average undrained shear strength of clay, average undrained shear strength of clay along the shaft. So let me write it for cohesionless soil. All total, how it is coming. So total ultimate bearing capacity of single pile is your QB into AB plus Fs into AS, which is equal to Q0 NQ AB plus Q0 prime Ks prime tan delta AS. For layered soil, what will happen for layered soil, cohesionless soil? Layered soil, QU is equal to Q0 NQ AB plus P is equal to perimeter summation of Q0 prime Ks prime tan delta into delta L. So, P is equal to perimeter, delta is equal to delta L is equal to thickness of soil layer. So, all total, if I start with this for particularly first one, this is your using static bearing capacity equation. Then for C5 soil, if I am considering your Terzaghi's bearing capacity, that is your CNC Q0 NQ plus 0.5 gamma d n gamma into AB. So, that is the resistance of the base. For deep foundations 0.5 gamma d n gamma has been neglected to 0. AB is your sectional area of pile at base level, Q0 is equal to gamma L, L is equal to depth of amendment. For granular soil, QF is equal to AS into FS. Now, for base resist for cohesionless soil, frictional resistance is your AS Q0 prime Ks prime tan delta. Q0 prime is your average effective overburden pressure along the shaft length, Ks prime is your lateral earth pressure coefficient, delta is your angle of wall friction. For cohesive soil, QF is equal to AS alpha Cu bar. Alpha is equal to cohesion factor, Cu bar is equal to average untrained shear strength of clay along the shaft. Now, if I am writing all together cohesionless soils, so Qu is equal to QBAB plus FSAS. So, QBAB is equal to QBAB plus FSAS. If I write it, Q0 NQ into AB plus Q0 bar Ks bar tan delta into AS. For layered soil, the Q0 NQ AB, this is your base resistance. This will be fixed for particular layer. For other part of this shaft, it is a summation of Q0 prime Ks prime tan delta into delta L, delta is your thickness of your soil layer into your perimeter. So, next part is your how do I calculate base resistance and what are the different factors affecting. I think I will stop it here. So, next class I will do other part.